Спасибо. Всем привет. Меня зовут Себастьян. Я работаю в качестве евангелиста программного обеспечения для IBM. И я учу русский, но я еще плохо говорю, so I think it's better if I talk in English.
Hi and welcome to the session on Supersonic, Subatomic, Enterprise Java from the ground up. In this session, I'm going to introduce Quarkus to you and what it means for enterprise developers, and especially which features and which special things we should be curious about. So I'm going to talk about a project that I'm using, which is called Coffee Shop, and I use this Coffee Shop project as a Quarkus project. So this uses Quarkus dependencies, and if you're interested in Quarkus, then just go to the website quarkus.io, and you will find some information, and especially also the Start Coding subsite, code.quarkus.io, and then you can get started. In my case, I use an enterprise Java project that mainly uses known familiar EE APIs, if you've worked with these APIs before, and I use a bunch of Quarkus dependencies. So you can have a look into this list of dependencies, and I'm using Quarkus in version 1.3.2 with JDK 14 already, so that is supported. And then we're going to have a look into our Coffee Shop world. So first of all, how to build this project is, this is a Maven project, and then of course we could typically build it using Maven package, for example. And this will then build our application as an executable jar file. And this is already one of the interesting things in Quarkus, how it's being built. Because if we have a look into our build list, and this is going to be interesting later on, we have a Quarkus Maven plugin with a build phase here. After the typical compilation and test compilation steps. So this is done by the Quarkus Maven plugin, and this will then ultimately produce a runner jar, an executable jar that we can run and where we can start our application. But first of all, let's have a look at some code. And we're going to have a look at, first of all, our REST endpoint. So we will build an application where we can access some coffee from RESTful web services. And if you're familiar with EE APIs, you probably have seen JUGNsk resources like this at path annotation. If you're familiar with a Spring world, then you might see that this looks pretty much like Spring REST controllers. It's just like slightly different declarative API. Instead of at get, we would have these request mapping methods, annotations in Spring and so on. So it looks quite familiar. And this will be a JSON payloads over this /orders URL, and then we have some methods for at get, at post, and so on and so forth. So for us, that means we will get some coffee orders in JSON, and also we are able to produce some coffee, to basically order some coffee by posting to some resource and so on. So this is what I want to show you. I'm going to start this application, and then I will just access it and write some code. So what we could do is to just run java-jar. This targets Coffee Shop runner application, and then very quickly it will start up our Quarkus application, and it's already running. Yes, it's that quick. And we can go to localhost 8080 and then have a look at, for example, the coffee orders. And then in our case, that is empty because, well, there is nothing in the system. It's just an empty JSON array for now. Our orders for now will be stored in memory. So that means we can now order some coffee. Again, if you're familiar with EE APIs, you've probably seen this at valid annotation that comes from bean validation, not null as well. And that means this will be mapped also declaratively from JSON-B, that is also supported, from JSON into this Java object, and then automatically we will invoke these validation constraints. So that means in this case our type has to be set, so we must actually provide a type for the order when we want to post something here. And in our case that means, well, we cannot just post an empty JSON object. That would be a bad request, that doesn't work, but we need to provide our type. In our case, we want to create a coffee with some espresso type. So you can have a look. There are a few types available. We use espresso, and then we have an order in the system. Great. Let's have a look at these orders. Okay, that is already preparing. It has a link here and so on and so forth. So that is just available using JUGNsk APIs together with bean validation, with JSONB, and of course our business logic in CDI beans. So these are a few technologies that are supported in Quarkus as well. If we are familiar with that, then good news, we don't have to learn new stuff. We basically just annotate our classes, for example, with application scope beans, and then we can just do some things. So this is going to order some coffee and store the coffees in just, well, a concurrent hash map for now. We're going to change this later on, but basically now we're just storing our coffee orders in memory, and then we can, let's say, create another order, and then we have multiple orders in the system. Okay, but actually now what I want to do, and not just showing you some EE APIs, I actually want to show you some features while Quarkus is especially interesting from a developer efficiency perspective, because the developer experience is pretty good. We have a few tools available that makes it really efficient to code in Quarkus. So for example, the probably most well-known feature now is this Quarkus dev mode, Quarkus:dev for development mode, where actually this plugin is going to start up Quarkus in a development mode where it will listen for our source code changes, and it will automatically and very quickly reload our application. So what we can do now, let's do some live code here, and let's change something on the fly while the application is running. We can actually just change some things here. So for example, we have our application, and now that is up and running again. Of course, the list of orders is empty, but now let's include some health check, because out of the box we have some health check available that is, well, now empty. We want to fill another response here, and this comes from microprofile health. If you're familiar with that, that's another API that is supported in Quarkus. So again, if you're familiar with an EE world, that might be known already. So we say this is going to be implements, of course, a health check. Nope, not the response, but the interface here. And we're going to implement this for just our custom health check call. So this is going to be a health check response up for a coffee shop. And that already is sufficient. This is going to be a readiness health check for our readiness probe, for example, later in container orchestration and in Kubernetes, what I will show you. And this is already sufficient to basically ensure that we're going to have another health check probe, which tells us, well, the coffee shop is also now up. And you see what just happened. Actually, Quarkus under the hood will quickly reload the application and then just display the new contents here. And I can just keep this running the whole time while I'm in my development mode, and I can now change something in our application. So let's change another thing. Let's just include some more pricing information here. I have another property price, which, by the way, this is just an example. Never do floating point calculations with money in a real world. So we're going to have a price that is actually configurable. So two things that I want to show you with configuration. One is the price, and also we have some properties. This is another pragmatic way how to configure Quarkus application.properties under resources, where we have the version. This is just a version of our application, so to say. And assuming I want to start with the version, I want to include and inject the version here in my health check and just, emit it as well. So what I can do, I can just say, well, please inject that config property. And again, this is a known microprofile API, microprofile config. And I say this should be the version. And this is a version string, no, version. And I want to emit this in my health check. So now instead of up, I just say named. This is the named builder with some data. And I want to include my application version here and then build this response so that when I configure the version, this will be included as well. And then again, it will just quickly reload my application and now say, once it's up and running, oh, of course, it needs to be up as well. That's a good point. And then we'll just very quickly, you see how fast we can reload things and how fast we can just change stuff and stay in the development flow. It will change this resource for us. Also, what's interesting, if we change the version here in our properties file, so in the configuration, that also will trigger a change because Quarkus knows about this path and config as well. So that makes sense to reload also when we make some config changes. So this is quite helpful. But if you look into these configurations, now we want to configure some pricing, right? If I order some coffee, then, well, I want to have some price information depending on the type of drink. So let's include this here. In my resource, I don't want to change anything because the user is not supposed to set the price, but our business component here. So what I want to have is basically, well, something that calculates the price for us. We can outsource this into another bean that I call price calculator. Price calculator, which is again application scope bean, and we have something like, well, double again in this case, calculate price from a specific coffee order, for example. So for the order, we now going to calculate the price. And then later on in my coffee shop component, I can say, well, first of all, please inject this bean, inject this price calculator, and then use the price calculator here in order to set the price. So order set price from whatever the price calculator calculates for the order. So I think this makes sense. And well, now we actually have to set it. And well, now what we could do, we could say, well, please inject the config for these three different types as well. But that would not be the best solution, because then every time we get a new coffee type, we would need to extend that. So that's probably not the best way. Rather than we can also have a programmatic lookup for whatever the price is going to be. So for example, given from the type, I can say, well, return something like, let's say, get configured price. We're going to include another method, and this method is just going to return a double, and then we say, well, actually config provider, that is again a functionality by microprofile config, get the config and now get a value, and this is actually programmatic lookup. So we can write anything here as a key, and then please emit that as a double in our case, and as a key, well, it's gonna be, let's have a look, coffee.prices.something, so coffee.prices in our case, and then dot, well, whatever the type is gonna be. Let's say that's a name to lowercase, and it's a little bit long. Let's make a variable out of it. Coffee.prices.something, for example, espresso or pour over. So hopefully this will work, and then we can dynamically look up the price configuration. Okay, let's see whether this works. Good thing is we can very quickly just try this out. We restart our application, and then, well, we have to post something again. So I'm going to create a new espresso, for example, and just to try it, I'm going to create a latte as well. And then in our case for the orders, let's have a look. This doesn't, this resource doesn't emit the price information, but let's have a look into this sub resource here, 1.5 for the espresso and $3 or in whatever currency you want to calculate. And yes, this makes sense. This looks correct. So we have we can look up our configuration and then just set the price accordingly. Of course, we then could make some further checking and throw some exception if it's not valid. But the point is to show you how it works to access configuration also in a programmatic way. That is a feature of microprofile config, supported here as well. And the nice story is with this hard reload mechanism in the dev mode, we just have a very pragmatic way of just checking whether everything works here and just reloading while we're developing. And now let's continue. How to do testing. that is another interesting thing, because once we have, well, this mode of running our application in this development mode, then we also have a mode, well, where we can actually test quite quickly. So Quarkus ships with some Quarkus tests, but actually I'm usually not using these in my projects. Why? Because if you have such a mode where you run your application locally already, then you actually don't have to restart or start your application each and every time you run the tests, which is what still, as of recording this, a Quarkus test is doing. And now that means that my test, actually, my coffee shop IT for integration test, will just, well, connect something that is already running. So I have two tests here. One is just testing some deserializer. That is a normal test, which will be executed by Surefire in Maven. And this is an IT integration test, which will only be executed by the integration test phase. What is the difference? Let me just stop this real quick and say, okay, I want to have something like Maven package or Maven verify will be the same thing. And that means, well, it only runs my unit tests or Surefire tests. So everything that ends with test, T-E-S-T, and nothing else. So in this case, it just runs the test here, my deserializer test, and that's it. In another, let's run a Quarkus dev again. In another mode where I would run a Maven integration test from failsafe integration test, I could run this IT here from the command line, or of course I just say, well, I want to run it here directly in my IDE. And what this system is doing, this is just a delegate in my test scope that basically connects to my application and checks, well, whether certain conditions are being met. So this is encapsulating how we access our application, which means that for our test code, that is just quite clean. And also it's very, very efficient to run our tests, because we can simply start up our tests and they immediately will connect against the system that is already running. And once our IDE is initialized, that runs very quickly. It connects to the system here, and I expect one method, I think we changed it to fail, yes, so it expects, well, this to be 1, 2, 3, but it's actually 1, 2, 4. So we could either, again, just change our properties, which we can do, because you saw quite quickly this will just trigger a reload, and then we can rerun our tests within the IDE, or we rerun our tests if we started it from the command line using the Maven phase. Let me also show this to you. So this is my project just in a different terminal window. I can say Maven failsafe integration test, which now runs only the IT, the integration test. So we see the Maven failsafe plugin integration test, and this now runs our coffee shop IT, which now also works because my Quarkus is still running. So that is just a way to very efficiently test also from an end-to-end perspective. If you're interested in that, I have more material on how to do efficient system tests, even when we run with some database and some external system, how to set that up locally. Also works within Docker containers or within Docker Compose or Kubernetes if you want, and keep everything running while we are in this development mode, because it's just so much more efficient to not restart everything from scratch, even though Quarkus starts up very, very quickly. But still, in order to get very fast feedback, it's faster to just keep it running. And this hard reload mode allows us to do so. So I can change some production code, immediately reloads. I can re-execute some tests, some system tests also, immediately returns, because it just connects against something that is already running. All right, now let's go one step further and bring our application to the cloud and into a cloud native environment. Because ultimately, the point of Quarkus is that it's especially tailored for, well, anything that runs in a cloud native stack. So for example, a Kubernetes environment with some container orchestration. And I have a Kubernetes cluster here, which allows me, let's search for that, to run it in the cloud. So you could build up a Kubernetes cluster in any way you want. This uses IBM Cloud Managed Kubernetes. And I have a cluster deployed here in Frankfurt. And this uses my, well, kube control already, right? So I can say, well, kube control, please give me the services and so on and so forth. Give me the running pods. And that is empty for now. So what we can have, well, we need to actually deploy something that runs in a container. So first of all, we would need a container image, right? And there are many ways to do that. And one of the easiest is to just write a Docker file. And now it's interesting how we want to run Quarkus, because a lot of people correlate Quarkus with the native mode that it definitely enables us to do, and this is already a very interesting thing that I will show a little bit later. But also, it runs in a JVM mode, so I can run Quarkus just on any JVM that I would like, and then also run it in this way in a container in my Docker image here. So this is actually what I'm doing. So I will build my application. Let's build this once again, and just to be sure, let's clean up front. So I will build everything that builds also the Maven Quarkus plugin. And then I can build this into a Docker image, and then I can start it. So let's say Docker builds, I just call this coffee shop for now. Let's build it into this image, and then it will add, all of the dependencies, first of all, into this lib directory. That's actually how the application, the runner, is shaped, and then it will add my application. So let's do this again, just to show you something. When we rebuild our application, then in our case, only the code changes. So only the jar file that I'm building here, but typically my dependencies don't change, or not that often. And now if I have the build again, then it runs really quickly, because it just uses the cache up front, and then it only actually adds, my application, what has been changed in my application is tiny. It's just kilobytes and not megabytes, because everything else is contained in the lib folder. And this really makes a difference, and this really makes sense, especially on a containerized approach, because we have these layers. We have these container image layers that are actually cached. And it's not only true for building, it's even more so true for transmitting, for Docker push and Docker pulling our images, and then we save a lot of transmission time, especially if we are in a continuous delivery environment where we build our applications very often. So now we can actually run this. Let's first of all run it locally, Docker run with port 8080, and we say this is our coffee shop. So now it starts up our application, and of course it also starts up very quickly our Quarkus, and then in the same way we can just access localhost 8080, our health, and of course our orders, and order some coffee again. Let's do this again. We order some latte, and then we see, this also works and it's in the system. So this is now running our application in a Docker container locally. That is already very nice. So we see it's running here. Can stop it again. But ultimately, of course, we want to run it in a Kubernetes cluster in our cloud. So how to do this? Many ways, and actually Quarkus also ships with a way where it will generate the Kubernetes resources for you. I think it depends whether you want to do this. So from my view, it makes sense to still have a way to maintain the YAML files yourself, especially if you work together with some other DevOps engineers where you have a bigger project and need to somewhat maintain this. It depends what the approach is here, but ultimately the point is, once you have everything into a container, in a container image that you can just ship anywhere you want, then you already won, because you are in an environment where it of course supports to be executed in Kubernetes. So I have some YAMLs here, some Kubernetes service with my coffee shop. I have some Kubernetes deployment that will run something that I already distributed. I can access my health check. That makes sense as a readiness probe. And then actually, in my case, I also run an Istio environment, because this is an Istio cluster, so I have these Istio resources as well. Okay, let's now have a look into a cluster and deploy this. Just kube control, apply everything what's in this YAML file. Okay, great. Let's have a look into what our cluster is doing. We now have one pod that is just being initialized. So now it will just download the image for the first time and then create the pod. And then once that has been done, it will quickly start up our application. We have a service as well, and then we will be able to access the application over the cloud at the managed cloud instance and get some coffee over there. So once that is up and running, and you see this starts up very quickly, we can go and access our application. So now instead of localhost, I have a script that just gives me the IP address of my cluster, because now I'm actually executing this on the cloud, and then I say, well, the health check works here as well, and I can get some coffee orders. And of course, I can also order some coffee that now runs in this cloud environment. So I order some espresso and see that hopefully works. 201 created. And now I see that this order is in the system as well. So now we just created some coffee in the cloud by deploying our Quarkus application to Kubernetes. And what really makes sense is, well, why running this in containers? Because Kubernetes Quarkus is optimized to be executed in containerized environments with all of the resource consumption and the optimization that will be done via build time. I will talk a little bit about that later at the end. But before that, I want to show you two more things locally. First of all, how to, well, do some persistence, because for now we only store our coffee in memory, and also how to do some templating approach. So let's do the persistence. We have our coffee order that is persisted in our orders being here and just stored in this hash map. So we don't want this anymore. We actually immediately gonna delete this whole package. And well, now what to do instead? So what I will use is Quarkus with Hibernate, ORM, and Panache. So this is a framework. Well, Hibernate is probably known to you, but Panache is a new framework, a new way how to do persistence in Quarkus, and it enhances the concepts of JPA a little bit and gives us a little bit bigger or greater developer experience. So what I can do, this coffee order, let's make an entity out of it, a persistent entity. You probably know, well, this is an @entity, right? That's what we've been doing all the time for JPA. And let's define a table with some nice name as well. So this is going to be the orders here. And now it's already getting interesting. So now I could annotate all of these fields here. Or what I do instead, I say extends Panache entity or Panache entity base. In my case, the Panache entity base does not include an ID. So I have my ID right here because I want to do my UUID, which is supposed to be a generated value. And that is going to be a type, and then my price and this enum, that's fine. But actually what I'm going to do, and this now looks probably a little bit weird to us Java developers, what I'm going to say that all of these fields will be public. So I know this looks a little bit weird in the beginning, and I also had to fight with that thought, because we're used to do private and then getters and setters access all the time. But it basically is, well, we'll just make the access a little bit easier, since it's supposed to be properties that are going to be persistent, and then we just access these properties using getters and setters all the time. And also, if you don't like this approach, then you can always roll back to plain more Java beans, to POJOs, where you have private access and getters and setters, and then just annotate your private fields. That also works, of course. And you also don't have to extend this Panache entity or entity base. But what it gives you, and this is what we're going to see, this is really interesting. So we don't need the orders anymore. It gives you an easy possibility to just access, well, all of the persistence methods that we have here. So coffee order dot, and this will list all. So that is a static method that resides on this class. It's a little bit like the active record pattern, where we have now a possibility to list all of the coffee orders here. So that's quite interesting, because it's a very easy way and a convenient way to call this. And then I can say, well, please list all, or coffee orders find by ID, which is the ID here. Or in this case, well, first of all, ID, I don't need to set this. This will be set by the persistence. And set the price, but not like this, but basically say price, right? Because now it's just a public field, and then not store, but say, well, coffee order dot persist, and it's going to be the order. And then the order will be updated with the appropriate ID, because I need that for displaying my location HTTP header. and that's already it. So now it already made that code cleaner, and I can access these methods by the static methods. If I don't want this for some reason, or if I prefer another approach similar to what Spring Data does with Spring Data repositories, that is also possible. I can inject something that is called Panache repository, and then I don't have to extend this Panache entity. I can basically say, well, repository dot and then similar operations. That is a different way how to come up with some architecture or some way of coding this and implementing the persistence. But I think this is a very straightforward and clean solution to basically implement the persistence here. So what I will do now, my Quarkus is not running yet. I will first of all start some database that just starts a Docker container with a Postgres database. Why? Well, I need some database now. And of course, I need to configure something. I need to configure that database access. And it's quite convenient that we can configure this in the application.properties. Why? Because we included the JDBC driver for Postgres already. So all of that works. We just have to say, well, that's going to be a Quarkus persistence. This is going to be called coffee shop DB when I run it as a as main production mode for my Docker container, for example. And if I run this in a development mode, so this is something like a pseudo or meta property for the dev profile, which is active during the development mode. So then I can actually reconfigure specific properties to be different while in development mode. Same works for tests, same works for defining your own property profiles. Now that means in development mode I will access localhost. So in this case this actually works to say, well, just Maven Quarkus dev, and then I start up my Quarkus application here now with the persistence approach. So of course we made some mistake here. That's everything is live. Coffee order now. Cannot find symbol. Order resource, yes. So in the orders resource we're gonna access, well, the coffee orders, which now is a little bit different. So typically you would not run into this error. Depends how early you change it, but of course we don't have the getters and setters anymore. Now we access it like this. Let me just quickly recompile here. Again, good news is we just get this fast feedback very quickly and say, well, another compilation error. Price calculator, of course, also accesses the type, and now in our case that will be just order.type. And then I could also ask my IDE to recompile, but now I'm lazy. And then we see whether this build approach works within Maven. And then we'll start up our application. Now it will take slightly longer because it will initialize Hibernate and all the persistence while in development mode. And then we see what's going on here. By the way, you see that it also will have some debug port enabled per default, and that also works per default. If I attach to my running Quarkus, I can just live debug as well. I showed this in the past in some videos, so this is really convenient to stay in that development flow. All right, let's have a look into the orders, and I can now create some new order again for some espresso. And if I did everything right, of course not. That's a typical error. I always forget. Why? Because I come from the time when we did most of the things in EJBs. And what EJBs do, what CDI beans don't do for you, if you're familiar with that word, well, EJBs would start transactions. And in CDI, that is always the case. Of course, also in Quarkus, you have to tell, well, when you actually want to do something persistent. So in this case, I say, well, at transactional, at all of these methods, or of course on class level, so it is true for all of the methods. And then I have a transactional scoped here, and let me just like re-execute this again, so it will reload with my code change, and then I can create and store my order. Okay, great. I do this again, and now I want to see 2 orders in the system, and yes, this works. Now, if I'm brave enough, I actually just stop my application and start it up again. So depending on the properties I'm setting here, if I say, well, please only create my database, but please do not drop it afterwards, I hope that now, once it's starting up, my orders are still there, because now it's not in memory. Now it's actually in the database, in the Postgres database that I'm running. let's have a look into this. And yes, good news, my coffee orders are still there and I can create new ones. Great. Okay, that's about persistence. So this is one efficient way how to implement persistence with JPA and with Panache, this Hibernate ORM model. And another thing that I think is pretty cool in Quarkus is Qt for Qt templating engine. So what we can do, we can write templates, for example, HTML templates, use them, or email templates, or well, anything that you can template. But it's especially helpful with HTML from what I will now call orders controller. So what I can do here, I can say, well, this is supposed to be a controller for some coffee orders, and that is going to be, in my case, also a path for just slash that produces. So this is going to be a JUGNsk bean that emits some media type, not application JSON in this case, but text HTML. So this works. And then I can just emit something that will be rendered to a HTML page. So what we do here, we're just gonna emit some template. And this works with at resource path. So if you're wondering where all of these annotations come from, that's another Quarkus dependency that I include. That is the Qt. REST-easy Qt for the REST-easy integration as well. So this works here in my JUGNsk resources. REST-easy is the JUGNsk implementation. And I have a resource path with, let's say, that's index.html for my template. That's a Qt template, and I call this index template. And now I have the possibility to say, well, I have a get method on this path, on this root path, to say, well, please emit something that is called a template instance. So one particular instance of a rendered template if you want. And I now will emit this and say, well, index template dot instance, for example, or of course already with some data. So I can say, well, data, I actually want to add some entries. So my entries gonna be, well, the entries that I can load from my database, right? So I say, well, coffee shop, please give me the entries. So in my case, I say coffee shop dot get orders, or orders, not entries, orders. And in this case, this will be stored as orders, in this case a list. So that will be supported in the template. You will see this in a second. And just for the sake of the example, to make it a little bit easier, we also include some hello world, because that is something we can emit first. Now, where is our index.html? Well, answer, it doesn't exist yet. We will create one. And the templates per convention resides under templates, under resources, templates, in our case index.html. And then what I will say, well, I just create an HTML5 page here, where I say this is going to be the coffee orders. And then I have something like, in this case, hello. For my hello world. Okay, let's have a look whether all of this works. Curl localhost. In this case, I can access that. And then once we have reload here, we say, okay, well, this of course is no JSON, so this doesn't make sense, but it says hello world. Okay, great. But actually now it would make more sense to show this in a browser, to say, okay, this is going to be, well, hello world, easy. But now let's make it a little bit more interesting. I can say something like a different syntax here. That is now a for loop for all of my coffee orders here. So I will just remove my hello again. For the order in a coffee orders. I can say, well, please emit a specific order dot type. Something like this. And then we're going to see, well, these are 2 espressos. So now let's make this a little bit more HTML-like. Let's say that's an it's just the list here, and this is going to be this entry espresso, okay. And now let's have a look into our coffee orders, what else we had. So we see, well, there's a type, there's a status, and a price. So let's say a type and then status, order.status, and something like order.price. And this is just the example of a coffee order. So espresso preparing and $1.50. So we could, of course, like style this and so on and so forth. But the point is, how do we get the integration of our model, which in our case is the coffee shop orders, into a template? And that's one way. There are many resources out there how to use Qt and, of course, all of the other examples. So have a look into Quarkus guides. I think this is a nice way where it is documented how this works with a lot of examples. And this is one way how to use, well, these Qt templates. And of course, it works with all the build approach, and it also works with compiling your application down to a native approach, including your template here. So I think that's a quite nice way that is supported. Now, just a few more things how, well, basically how to justify Quarkus, yet another runtime or another framework if you want. And I think one of the biggest improvements that Quarkus made, and what is really the groundbreaking part here, is the optimization at build time. So why? If you look into the Maven builds, then if we do, let's do this again, just with a clean. If you build your application, you're going to have the Maven Quarkus plugin here that does the build. And what it does, it basically does a lot of optimization at build time already. So when we write applications with EE APIs or using Spring, we use a lot of declarative programming and a lot of nice ways of defining beans in a very efficient way for us developers. So we just say, at something like at path or at application scope, and that will be resolvable later on. But of course, somebody has to do all this heavy lifting at runtime, typically for the container, for the runtime. But now what this build phase is doing, it's already resolving all of these loose ends and basically produces code that does not have all of this inversion of control anymore. So we don't use any reflection or anything, any dynamic lookup once that has been built together. So this is the reason why Quarkus starts up that quickly, and where we have these hot reload mechanisms where it just works with very short waiting times and also with low resource consumption. If you need to convince your CTO or manager, or if you just want to have a look into try this out, just look at the homepage here and you see some comparison. What that means, well, if you run something in a more traditional stack like Spring, or if you run Quarkus in different modes, and for example JVM mode or in the native mode. Now for the native mode, it depends what your main goal is. You get less resource consumption, but also due to the nature how a JVM works, you will get actually less throughput than on a JVM mode. And you also get one bigger, actually a smaller image, but bigger images diffs, because you don't have the layered approach that you have in a JVM mode. So what I showed you with the Docker images, this approach that you have the lib folder with your jar files and a small, just kilobyte size jar, that only works with the JVM mode. What you can have a look into, what I was running is an alternative JVM. So I was running OpenJ9. That is actually a JVM that has less resource consumption, because it originally comes from the world where we had low memory footprint of some embedded and mobile applications. And this is actually a way where you're really enabled to run Quarkus with an even better performance footprint and memory consumption than running just stock OpenJDK. So I think this makes a lot of sense, and actually in most of my projects now I use Quarkus in the JVM mode using OpenJ9. So this is what this Docker file produces for you. It's quite easy. You just have to swap the base image and then it runs a different Java, but that's also Java. It's just a different JVM. And then you can add your application here in this jar file. And I think this really makes sense for, well, how you run your application, especially when you need to convince well, the technical decision makers and maybe DevOps engineers to say, okay, how do we run our application, and do we have the experience to run, you know, something that is a JVM as opposed to something that is native, where we cannot interact with it in production like we now can with our JVM workloads. So that's also a thing to consider, and you know, to justify this. So I think that's quite interesting. And as some takeaways, I think Quarkus is a very interesting technology, and it's the modern way how to do cloud-native Java. And it's especially cool that it builds upon known APIs. So we don't have to relearn the world for new reason. We're probably familiar with JUGNsk, with CDI, with all of these things that I was coding. That's usually not new stuff, or it looks very familiar to known concepts already. And also the fact that Quarkus cares a lot about the developer experience. So you saw this in how to configure an application. It's very straightforward in this property file. You saw the development mode and the way how to get started. So that experience also improves a lot and gets better and better. And I think it's really fun to write applications in Quarkus. And now for projects, it's especially interesting if you have existing investment and existing technology in EE. It's actually possible to migrate an application to Quarkus. You sometimes have to change some bits and pieces, but ultimately the EE APIs are supported, and especially about the knowledge transfer. So if you have developers in your team who are familiar with these APIs, well, then also the transfer is quite straightforward. You don't have to relearn, well, everything from scratch. Then with Quarkus you can go native thanks to these build time optimizations, but also you don't have to. There is not a one-on-one correlation from Quarkus to native GraalVM builds. Well, it really makes sense to run it just on a JVM mode, and you get all of the optimizations there as well. It starts up really quickly in just JVM mode, especially if you use another JVM such as OpenJ9 like I did. And if you want to get into it, Quarkus guides are your friend. Have a look into quarkus.io, and especially the guides. They are fun to read, I think, and then also help a lot in how to get started in your Quarkus application and how to get there. So I hope this was interesting and fun to watch. Thanks a lot for your attention. If you want to have a look at the code, just look at the first link, Quarkus 101, and you will find all of the resources there. And of course, you can just contact me on Twitter or on any other channel. You can also check out my book if you want. And thanks a lot for watching. Bye.
Other than that, I have two more things. Actually, I brought some presents. I have a book that we wrote at IBM developing open cloud native microservices, which uses Java EE and microprofile APIs. It uses Liberty, which is a different runtime here, and I have some socks. Right, so these socks are pretty cool. This is a different color, I think. Might not as warm enough to use them, but yeah. Some question: who can tell me what is the name of the annotation to declaratively inject a configuration using microprofile? Just shout it out. Config property, yes. You get to choose? The book, awesome, I like that choice. Okay, thank you very much. And second question, what was the annotation to inject the name of the templating file? Resource path was first. So thank you very much. You just grab them. You just want some socks. And thank you very much, Spasibo Bolshoi, for your attention.